This lesson is on exponential functions. So the first thing we're going to do is we're going to define what a exponential function looks like. So exponential function is in the form of f of x equals a times b to the x power, where f of x is going to be your range and x is going to be your domain, which means a and b are both going to be numbers. So this looks very different from our linear function, which would be y equals mx plus b. This is the first time we've actually seen an exponent be our independent variable. Now, with that comes a couple of stipulations on what our values for a and b can be. So, for example, a can never equal 0. And the reason this is because this would not be an exponential function, it would actually be a linear function, because 0 times any base to any power is always going to equal 0, which would give us a horizontal line on the x-axis. Our second stipulation is that b has to be greater than 0. This means it cannot equal 0 or be negative. And again, if it was equal to 0, that would create an issue as far as having powers of 0 would equal 0, or it would be undefined if you try to plug a negative power in. And same thing with a negative base. And then finally, b cannot equal 1. And this is also because this would create a linear function, because 1 to any power, whether it's negative, positive, or 0, is always going to be 1, which means no matter what I plug in here for my x's, I'd always end up with the same constant value, creating a constant linear function. So there are two types of exponential functions. Those two types are exponential growth and exponential decay. So exponential growth is when you are multiplying by a constant factor that is greater than 1. So think of times 2, times 3, times 4, times 100. That's going to give you an exponential growth function. An exponential decay function is when you're multiplying by a constant factor that is greater than 0, but less than 1. So think of like when you multiply by 1/2 or 1/3 or 2/3 or 5/6. It's those fractions and decimals in between 0 and 1. So we are going to look at two scenarios, one that is an exponential growth scenario and one that is an exponential decay scenario. The first one comes from a viral video that occurred in 2007 called Charlie Bit Me. And I'm actually going to show you this video because you may not have seen it, since 2007 was quite some time ago. So without further ado, I'm going to let you watch the video.
Charlie bit me. Ouch! Ouch! Ouch, Charlie! Ow! Charlie, that really hurts! No, Charlie bit me. And that really hurt, Charlie, and it's still hurting.
So that was the video, Charlie Bit Me. Sorry the audio wasn't the best, but you probably got the gist of what was going on. So the next part is a little bit of a fabrication, just to go with our problem. So it says, suppose the boy's father shared it with the boy's grandpa, who then shared it with 2 more people, who then shared it with 2 more people, and so on. So we're given this function, y equals 2 to the x power. And you'll notice this does fit our definition up here, because the a, the number in front, is an understood 1. So this is really y equals 1 times 2 to the x power. So a is 1, it's not 0. The base is 2, which again fits both stipulations. It's more than 0 and it's not 1. And then the x is the power, and then y and f of x are interchangeable. So down here, when we first start, the boy's father shares it with the grandpa. That's one person. So in our table here, our 0 stage is going to get a 1. He's shared with one person. Well, then Grandpa, who loves his grandsons, he shares it with 2 more people. So now in stage 1, two new people have seen the video. And then in stage 2, those 2 people share it with 2 people. So now we're up to 4 people. And if you see, if we plug this in, if we did 1, 2 to the first power would be 2, 2 to the second power would be 4. So the third stage, 2 to the third power would be 8, 2 to the fourth power would be 16, and we just keep doing this pattern, 32, and 64. So when we go to graph this, we would start at 0, 1, which would be really close down here, 1, 2, 3, 2, 4, 3 zooms up to 8, and then when we get to the 6th stage, it really zooms up here to 64. So you can see we have this curve to our graph. It's not linear. It starts out pretty slowly, but then quickly gains speed over time. And I'm going to connect these points so that we can really see the function. And also to show that it continues on, because, I mean, this could keep going for a long time. I think this ended up with 800-something million views when it was all said and done. So while there are, of course, other videos with many more views nowadays, considering that happened in 2007, that's a pretty viral video for that time. So the next question is this a discrete or continuous situation? It really depends on how you interpret it. If you say that, it's the number of people watching the video, then you might say it's discrete. If you're just counting the number of views, maybe if they only watch part of the video, it could be considered continuous. So it's really how you interpret it here. I'm going to say that if, even if you just watch part of it, it counts as a view. So I'm going to call this continuous. But again, there can be an argument for discrete. And then our domain is going to be all values greater than or equal to 0 in this case, because we can't go back in time. We're not going negative. So we're just going to call this x is greater than or equal to 0. And then our range, notice it starts at 1 in our table and in our graph. So y is greater than or equal to 1. And again, we don't know how long this is going to go, so we're just going to say greater than 1 for now. At the moment, it's got 800-something million views, but it could eventually end up with billions of views. We don't know. All right, our second situation is March Madness. So March Madness is a series of basketball games held every spring leading up to the NCAA Men's Division I National Championship. The tournament begins with 64 teams and concludes with a national champion. In the first round, each one of the teams plays another team in the tournament, and the winner of each game moves on to the next round. This process continues until there are only 2 teams left to play for the national championship. So again, you can see this function here, and it fits our y equals a times b to the x. So in this case, our a is 64. It's the number of teams we're starting with. And our 1/2 is that we're basically having how many people in each round. So when we start 0, we start with 64 teams. And then those 64 teams, you'd have 32 teams playing, 32 games going at the same time, 2 teams playing. So at the end of that first round, half of those teams, are eliminated. So you'd only have 32 left. And then those 32 teams play, half of them are going to be eliminated. So then you'd have 16. Again, half of them would be eliminated, so then you'd have 8. Half of that is 4. Half of 4 is 2. So then finally by the 6th round, you'd have 1, which is your final winner. So when we go to graph this, we'd start here at 0, 64. Then we go down really quickly down to 32. 2, 16. 3, 8. So notice here we can see, and again I'm going to draw this line just so we can, this curve, so we can see what's going on. So we get this kind of smooth, we should have a smooth curve, but we start up high and we get lower. So And our first one on Charlie Bit Me, it was growing. It started out really slow and it jumped up really fast. And this one is kind of the opposite. We start up really high and then we're cutting things down really quickly and then it kind of evens out. So in this case, I don't think there's much argument. This is definitely a discrete situation because we're talking about teams and the number of teams per round. So this is discrete. So I really shouldn't have a line here. Again, I just drew it to show what was happening. So if it's discrete, that means our domain is going to be a list of numbers. So our domain is going to be each round. So 0, 1, 2, 3, 4, 5, 6. And our range is going to be the number of teams left. So again, we tend to put this in order. So 1, 2, 4, 8, 16, 32, and 64. So again, that is Charlie Bit Me and March Madness. So our exponential growth and our exponential decay model.